Hi students, this is Sivakumar, 10th standard mathematics. Now chapter number 3, algebra. Chapter number 3, algebra. Solving the simultaneous equations of three unknowns, so three variables. These are the steps to be followed in solving the equations. Now read, you listen carefully. By taking any two equations from the given three, first multiply by some suitable non-zero constant to make the coefficient of one variable, either x or y or z, numerically equal. Step number 2. Eliminate one of the variables whose coefficients are numerically equal from the equations. Step number 3. Eliminate the same variable from another pair. And step number 4. Now we have only two equations in two variables, because already we have eliminated one variable, so only two variables left. So therefore we have only two equations left. So three equations been reduced to two equations after eliminating one variable. Step number 5. Solve the two equations using any method studied in earlier classes. Anyway, we are going to solve the equations by elimination method. Already I have learnt solving the equations of three unknowns by elimination method, substitution method and cross multiplication method in 9th standard. Right? Now step number 6. The remaining variable is then found by substituting in any one of the given equations. Particularly elimination method, that is a familiar method for you, already have learnt in 9th standard. Now, very important note. First one, if you obtain a false equation such as 0 equals 1, 0 equals any constant. So only example given 0 equals 1. It can be any number. If 0 equals any constant in any of the steps, then the system has no solution. Suppose if you are getting 0 equals 0, such identity if you get, the system has infinitely many solutions. Once again, 0 equals any number other than 0. Any number other than 0. System has no solution. If 0 equals 0, then the system has infinitely many solutions. Okay. Now we can get into that exercise. Exercise 3.1. Question number 1. Solve the following system of linear equations in three variables. What are the three variables? X, y and z. So you are given three equations with the three variables. Okay. First subdivision. I am going to work out the first subdivision. Let it be equation number 1, 2 and 3. Right, now I am going to solve 1 and 2. Solving 1 and 2. Take any one pair. Can take 1 2 or 2 3 or 1 3. I am taking 1 and 2 first. Out of these three variables x, y, z, any one variable can be eliminated, either x or y or z. I am going to eliminate x. See, once you decide which variable to be eliminated, then you have to look at the coefficients. Here the coefficient of x is 1, here the coefficient of x is 2. Both the coefficient must be same, then only you can solve. So what to do for that? Since we have 2, the first equation should be multiplied by 2. Look at that. This is equation into 2, which implies each and every variable should be multiplied by 2. 2 into x, 2x, plus 2 into y, 2y, plus 2 into z, 2z. Even you have to multiply 2 with 5. 5 2s are 10. Then write the second equation as it is. 2x minus y plus z, that is equal to 9. Look at that, already have decided which variable to be eliminated, x only. Look at the coefficient of x here, 2. Here also 2. Since both the coefficients are equal, then we have to change the sign. Then only you can eliminate. So plus 2 becomes minus 2, minus becomes plus, and plus becomes minus. Here plus 9 becomes minus 9. Now we have to consider the changed sign only. Now plus 2x minus 2x direct cancel. A plus 2y, have to consider this plus y. So plus y plus 2y, that is plus 1y plus 2y, that is equal to 3y. 2z minus 1z. 2z minus 1z, that is equal to z. 10 minus 9, that is equal to 1. So equation number 4. Already we have 3 equations. Now equation number 4. Now we have to take another pair, either 1 and 3 or 2 and 3. Now I am going to take 1 and 3 because here x, here also x, can easily eliminate. Even you can take 2 and 3. So instead of taking 2 and 3, if you take 1 and 3, that will be easy for you, right? So equation number 1 and equation number 3, write as it is. Equation number 1, please. X plus y plus z, that is equal to 5. Equation number 3, x minus 2y plus 3z, that is equal to 16. Here, which variable we have eliminated? X. The same x has to be eliminated here also. Okay. Look at that. Here plus 1x, same coefficients, so you have to change the sign. Plus becomes minus, minus becomes plus, and plus becomes minus, and plus becomes minus. Plus x minus x get cancelled. 1y plus 2y, 1 plus 2, that is equal to 3y. 1z minus 3z, 1z minus 3z, that is equal to minus 2z, because 1 minus 3, that is equal to minus 2. 5 minus 16, that is equal to minus 11. That is equation number 5. Now according to that, already we have discussed that what are the steps to be followed in solving the simultaneous equations of 3 variables. We are following that only. Now 3 equations have been reduced to 2 equations. Look at that. In these 2 equations we have only 2 variables, y and z. Okay. Now I am going to solve equation 4 and 5. Solving 4th equation and 5th equation. In 4th equation and 5th equation we have only 2 variables. What are they? Y and z. Can eliminate any one of them, either y or z. I am going to eliminate y because here 3y, here also 3. We can directly cancel by changing the signs. So solving 4 and 5, equation 4 and 5 as it is. 3y plus z equals 1, and 3y minus 2z, that is equal to minus 11. Both the coefficients are equal, right? I'm going to change the signs. Plus becomes minus, minus become plus, and minus become plus. Plus 3y minus 3y get cancelled. Here plus 2 plus 1, plus 2 plus 1, that is equal to plus 3z. 1 plus 11, that is equal to 12. Therefore z, that is equal to 12. This multiplication of 3, when it comes to the right hand side of equal sign, it comes to the division. You know that. 12 by 3. So 12 by 3, that is equal to 4. We got the value of z. Now you can substitute the value of z in equation number 4 or 5. Right? Not 1, 2, 3, 4 or 5 only. So equation number 4. I take 4. Even you can take 5. So 4th equation, 3y plus z. 3y write as it is, plus z. What is value of z? 4. That is equal to 1. Okay. 3y plus z value is 4, that is equal to 1. 3y, that is equal to 1 plus 4 comes right hand side, minus 4. 3y, that is equal to 1 minus 4, you know very well, that is minus 3. Y, that is equal to minus 3 divided by 3. Therefore y, that is equal to minus 1. Finally you have to find out the value of x. Which variable we have eliminated at the beginning? X only, right? So you have to find out x at the last. So you can consider any one of the 3 equations for finding the value of x. Which one is easy? I consider number 1. Equation 1 implies, look at that equation, x plus y plus z equals 5. X plus y. What is the value of y? Minus 1. Plus z. What is the value of z? 4. That is equal to what is in the right hand side? 5. X. 4 minus 1, that is equal to plus 3. That is equal to 5. X, that is equal to 5. Plus 3 comes right hand side, minus 3. X, that is equal to 2. So we have the value of x, y and z. So this is called the unique solution. Unique means only one solution. Finally write the solution. X comma y comma z. Write them in brackets. X value 2, y value minus 1 and z value 4. You can verify whether the answer is correct or wrong. This is for our reference. No mark for the verification part. So which equation we haven't taken? We took that first equation at the last, correct? Now these two equations we haven't taken, so you can consider either 2 or 3 for verification part. I take second equation. Okay, second equation, LHS 2x minus y plus z. I take only LHS. 2 into x value minus y value plus z value. X value 2, y value minus 1, z value 4. 2 into 2, that is equal to 4, minus into minus plus 1 plus 4. 4 plus 1, sorry, yeah, correct only. 4 plus 1, 5, 5 plus 4, that is equal to 9. Look at that. What is in RHS? 9. Yes, that is RHS of equation number 2. Now LHS and RHS are equal. So our answer is absolutely correct. Now subdivision number 1 is over. Then I will be teaching problem number 1, subdivision 2 in the next video. Thank you, children.